So we have discussed three forces till now. One is the gravitational force. The first one is the gravitational force. All of you are aware that gravitational force acts perpendicular to the ground and is always directed towards the center of the earth. Number one. Then the second one was the contact force. Contact force was reaction force. All of us are aware about two different components of reaction force: normal reaction and friction, and the angle of friction. We discussed that also. So reaction force is, if there is no friction, then reaction and normal reaction are one and the same. They are perpendicular to the contact surface and is exerted by one object on the other object in which it is in contact. The third one was tension. Tension is a force which is always directed away from the body and along the string. Naisha, we have done this. I think we have done this. Yes or no?
Yes, sir.
Okay. So now we are discussing how to solve problems in laws of motion. Okay. So I have given you an algorithm to solve, to move ahead. First one is draw the free body, identify the system. Identify the system. And in this, how should the system be chosen? The system should be so chosen such that the system should be so chosen such that there is no relative motion between its constituent bodies. Okay. Second one is draw the free body diagram. Draw the free body diagram. Okay. The third one is resolve the forces. Naisha, did we do this?
Yes, sir.
Okay. Along the probable or actual direction of motion. Or actual direction of motion. And perpendicular to it. Okay. Then the fourth one was write force equations and solve for required parameters. Okay. So these are the four steps to solve, right? Oh. So I'll take a very simple case first, and then, so this is a block, and the block is kept on the ground, and it is pulled along by a force of, say, 10 or force F. Okay. The angle with the horizontal which the force makes is theta. This is weight mg. And this is normal reaction N. All of us are aware about it. What you need to do is you want to, so this was, these were not there. This was not shown. And M is there, right? Mass of the block is there. So you have to find what is the angle, what is the acceleration of the block. And we are assuming that the block does not takes off from this surface. So we will draw the free body diagram of the block. There is only one block here. So that is the system here. So this is normal reaction. This is weight mg. And we have drawn the free body diagram now. Next step is we will resolve the forces, which is the probable direction of motion. Of course, the direction of motion is horizontal. So we will resolve the force along this and this direction. ठीक है. So the probable direction is F cos theta. We have to resolve the forces, right? Normal reaction and friction need not, sorry, mg need not have to be resolved. We can only resolve only force and F cos theta and F sin theta. So now, once you have resolved the force, all of you please remember this. This you don't do. Once you have resolved the force, you can remove it from the diagram. Okay, you should remove it, but ठीक है, usually remove होता नहीं है तो उसको cancel करके दिखाओ कि ये नहीं है अब. ठीक है, so that there is no confusion. So this block will accelerate in the forward direction. So the net force is F cos theta, and this is equal to mass into acceleration. And the net force in the vertical direction is how much? It's F sin theta, upward direction. Net force in the upward direction is F sin theta plus N. I took the upward direction as positive. I asked you what is the net force in the upward direction. So net force may take those forces as positive which are in that direction, and opposite to that, if there are any forces, subtract it, minus mg. And since there is no acceleration, so mass into acceleration is 0. So from here we get n is equal to mg minus f sin theta. And from here we get acceleration as f cos theta by m. So it was a very simple question to address. If you have understood it, please type or please say yes. And
yes,
we have followed the
Yes, sir.
steps. We have followed the steps. That's what I wanted to show you. Let me do one more question for you. चलो एक और करते हैं आप जल्दी से. अच्छा इसको लिख लो पहले. ये लिख लिया है सबने? All of you, if you have written it. Okay, 2 minutes. Hi Tanushri, how are you? I am recording it for you. I'll send the session to you. You attended the previous session, Tanushri, where we did this, how to solve problems in the algorithm which I gave. I hope all of you have attended the previous session.
The last class I came only on Monday.
That was Monday only, na? Monday. Then there was no class on Tuesday. What was on Tuesday? Tuesday we
Sir,
did.
on Monday there was no class. You were out of station, and on
हाँ.
Tuesday we
but
started.
Tuesday
class.
I came and then
ठीक.
yesterday we didn't have class.
हाँ बस ठीक है perfectly fine. ठीक है चलेगा. Copy this quickly. Chalo. I think all of you are done. So let's do this one also. See, why I'm giving you, why we are doing this simple problems is just to follow the steps, okay? Once you are well versed in the steps, तो फिर कोई दिक्कत ही नहीं. ठीक है? So this is an inclined plane. And on this inclined plane, that there is a block which is tied to this string, and the string is tied to a point in the inclined plane. Okay. So the mass of the block is m. Okay. You need to find the tension in the string and the normal reaction exerted by the block on the string. Sorry, on the inclined plane. So the system is what? The system is block. So these are the forces acting on the block. Normal reaction, tension, and weight. Normal reaction, weight, and tension, right? So what we will do is, what is the probable direction of motion? Naisha, what is the probable direction of motion for this block?
Downwards along the
Obviously,
plane.
yeah. So the probable direction of motion is downwards. So since the probable direction of motion is downwards, it is in that direction only we will be resolving the forces and perpendicular to it, right? So this is the direction, and this is the direction in which we will resolve all the forces. Okay. So we have this mg cos theta here, and we have this mg sin theta in this direction. This is mg cos theta, this is mg sin theta. Okay. Now, Avirupa Nath, tell me what is the net force acting in the downward direction, Avirupa?
So if sine theta,
mg sin theta, beta. mg sin
हाँ
theta
mg
minus t.
minus mg sine theta plus
Minus
n
t. नहीं beta,
minus
downward. Along the incline downwards. इस तरफ, what is the net force acting? So net force acting is mg sin theta
mg
minus
sine
t.
हाँ
See, देखो क्या करते हैं ना हम लोग यहाँ पे क्या करते हैं, जब हमारा नेट फोर्स डाउनवर्ड्स पूछा मैंने, है ना, तो इसका मतलब क्या हुआ, द डाउनवर्ड डायरेक्शन इज टेकन एज पॉजिटिव, ठीक है?
हाँ
तो उसके ऑपोजिट वाला जो डायरेक्शन होगा वो क्या होगा, नेगेटिव होगा, ठीक
नेगेटिव
है, और ये पॉजिटिव होगा। तो नेट फोर्स पूछा है मैंने क्या पूछा है, नेट फोर्स। तो नेट फोर्स पूछा है, तो इसका मतलब मुझे सारे फोर्सेस को लेके आना है इक्वेशन में। So those forces which are downwards are treated positive. Those forces which are taken upwards are treated negative. So this is the net force. Understood?
yes
गलती नहीं करना बेटा इसमें। फिर then it is mass into acceleration, which is 0. So we have T is equal to mg sine of theta. I hope all of you understood this. Yes or no? Now, Avirupa Vashisht, please tell me what is the net force acting up the incline perpendicular to it in this direction. Arpita Vashisht.
Yes, sir.
What is the net force acting in this direction?
Sir, normal reaction.
नेट पूछा है बेटा, नेट फोर्स। ये वाला नेट फोर्स समझ में आया था?
Yes, sir.
तो फिर ये वाला नेट फोर्स बताओ क्या सिखाया था, फिर से देखो, ठीक है? इस डायरेक्शन में मैंने पूछा इस डायरेक्शन में नेट फोर्स क्या होगा। सो दिस डायरेक्शन शुड बी टेकन एज पॉजिटिव एंड दिस डायरेक्शन शुड बी टेकन एज नेगेटिव। ऑल ऑफ यू प्लीज पे अटेंशन, दिस इज अ वेरी स्मॉल थिंग, बट इट मतलब ये इतना इंपॉर्टेंट है और ये हमेशा गलती होती है, ठीक है? जब बहुत बड़े बड़े क्वेश्चंस होते हैं एंड यू कमिट वन स्मॉल मिस्टेक, इट इज ऑलवेज कैरी फॉरवर्डेड टू ऑल द इक्वेशंस, फिर टाइम वेस्ट होता है, राइट? सो in the force equation, all the forces needs to be included now. So net force का मतलब इस तरफ जो force है वो क्या है, n है, and opposite to it is what, mg cos theta. So it is minus mg cos theta. अर्पिता समझ आया बेटा? ये net
Yes,
force हुआ.
sir.
This should be equated to 0. So n is equal to mg cos of theta. I hope all of you understood this.
मैंने चैट में भेजा था।
हाँ, very good. Please note it quickly. Please get, make this concept very clear, the net force, right? Tanushri, you understood?
Yes, sir.
Okay. And type done in the comment window, huh? Once you are done. Chalo, I hope all of you are done with it. It's a very simple question to answer. Chalo. So next, let's see pulley block questions. Okay. Pulley block questions. Now, let's define what is an ideal pulley first. So pulley is an ideal pulley, and ideal pulley is ideal pulley is massless and frictionless. Ideal pulley is massless and frictionless. Okay. And string which we will be using in the pulley will be, string is light. That is again massless only. Okay. Massless and light and inextensible. Inextensible. Okay. So pulley is ideal pulley and it is massless and frictionless, and string is ideal string and it is massless, light and inextensible. Okay. So I'll give you the examples very quickly because I think most of you are aware of these examples. But again, why we are doing it? Because concept ठीक से पकड़ना है, ठीक है? So the pulley is hinged from the ceiling like this. This is the string passing over it. So this is mass M1, this is mass M2. So we want to find the pulley is an ideal pulley, the string is an ideal string, and we are planning to find the acceleration of the blocks, right? So first of all, we will draw the free body diagram. There are only, how many forces are acting on M1? Ek second, Vaidehi. How many forces are acting on M1?
Sir, mg and tension P.
Very good. It's M1 mg and tension is M1g and tension T is acting on the M1, and on M2 it is M2g and tension only. So since there is one single string, it's a one single string, see, right? So this single string will have one single tension. Okay. Strings में tension नहीं बदलता है. The pulley is only, it is not changing. Why? Because the pulley is massless and inextensible, and the string is light and inextensible, or else the tension will change. Okay. So all of you assume that this is going down and this is going up. Write down the force equations for these two blocks quickly. Chalo. So,
Sir, done.
very good. It's M1G. The net force for this M1, the net force for this block M1 is, एक second. Anushka, what is the net force for this block M1G? Sorry, M1, net force downwards.
m1g minus t is equals to mass into acceleration.
Very good. It's mass m1.
Into acceleration.
So it's m1 into acceleration a. So अरे ये क्या कर रहा है? एक मिनट है. So it's m1g minus t is equal to m1 into a. And the net force acting on this block m2 is t minus m2g upwards is equal to m2 into a. Now to solve it for a and t, what we do is we just add these two. It's m1g minus m2g is equal to m1 plus m2 into a. So a is, it's m1 minus m2 into g upon m1 plus m2. I hope all of you understood this. Yes or no?
Yes, sir.
Yes, sir.
Very good. Good, Vishwa. You have attended it nicely. Chalo, shabash. Shriya, Shanvi, Vishwa, Tanushri, Riya, Lonika, Naisha. Understood or not?
Yes, sir, understood.
Yes, sir.
Yes, sir.
Chalo, shabash. Copy this quickly. Please remember the conditions, huh?
Sir, so if there is no acceleration given, then can we just conclude that m1 is equal to m2?
Huh. In that case, when you add those two, it will be gone, na?
Hmm.
If A is 0, m1 is equal to m2.
Okay.
ये सब आप पढ़ चुके हो. मैं इसलिए पढ़ा रहा हूँ जस्ट फॉर द सेक ऑफ कि नथिंग शुड बी लेफ्ट अनटच्ड. ठीक है, वी हैव डन इट. ये होना चाहिए, इंपॉर्टेंट ये है.
मुझे एक चीज पूछनी थी, अभी पूछू या फिर क्लास के बाद? सर एक्चुअली
इससे रिलेटेड है
कैलोरीमेट्री
तो अभी पूछ लो. नहीं, कैलोरीमेट्री
नहीं
अभी
सर,
नहीं पूछना है.
नहीं वो मुझे वीडियो नहीं मिल रहा, आप मुझे क्लास के बाद दिखा सकते हो?
हाँ, मैं कोशिश करता हूँ. मैं एक काम करता हूँ, मैं तुम्हें ढूंढ के भेज देता हूँ. ठीक है, लिंक आई सेंड यू द
सर
लिंक.
आप वो कर देना, क्योंकि अभी मेरा एग्जाम आ रहा है वो थर्मल फिजिक्स
हाँ,
के.
हाँ. Noted? I think all of you noted it. So now let's learn a new thing today. Okay. This is about solving problems. Simple hai. Every time you will be doing this thing again and again, right? For every problem, you will identify the system, draw the free body diagram, resolve the forces, write force equations, and solve. That's it. Now we are adding a new element to this, that is constraint relations. Now, what is a constraint? Anybody? Chalo, let's ask Naisha. Naisha, what is a constraint? Naisha, am I audible to you?
Yes, sir.
Yeah, what is a constraint?
I'll explain.
Shreya says restriction. Yes, Shreya, very good. It's restriction. Hai na? Or limitation, you can say. It's limitation. Okay. So there is a wonderful usage of this word. One of my mentors, he used to do it. Constraint is perfection is making the best efforts within the constraints of space, time, and resources. Right. So constraint is limitation. And in this mechanics case, there will be three constraints which we'll be dealing with. There are three constraints which we'll be dealing with. One is the string constraint. In this, what is constraint is? The string is light and inextensible, right? So inextensible is a constraint. So length of the string is a constraint here. Okay. Second one is wedge constraint. Now, what is this wedge constraint? Wedge constraint is the dimensions of the wedge are a constraint here, right? They are fixed, they are rigid. Okay. Dimensions are a constraint in this case. And the last one is rod constraint. Here again, the length of the rod is a constraint. Because rod will be a rigid rod, right? So length of the rod is a constraint. Okay. चलो तो मैं तुमको स्ट्रिंग कंस्ट्रेंट का एल्गो देता हूं, इसको प्लीज कॉपी करो क्विकली. Tanushree, you understood or not the previous two cases, the examples? ठीक है. All of you, please note it quickly.
Sir, एक बार पेज पिछले वाला पेज ऊपर देखो.
Dimensions of the wedge.
Sir, do we have to note this or the mind
ये
map?
भी लिख लो, इसको 2 मिनट लगेगा तुम्हें लिखने में.
अच्छा, ठीक है.
चलो, copy this quickly. I'll explain every point to you. Just copy it quickly. Once you are done copying it, please type done in the comment window. Huh? सानवी दास, आपको समझ आ रहा है? ठीक है बेटा। Chalo, I hope all of you have done. So I'll explain each and every point to you. So first of all, always remember that string constraints are used only in compound pulley system. So what is a compound pulley system? Please pay attention. I'm just taking you to this example and I'll explain every step to you. See, the question may seems to be a simple question, but once you apply it methodically, believe me, this is the next level thought. Okay. So this is a pulley. And one of the ends of the string is tied to the wall. And the other end is tied to this block. Okay. The pulley is now pulled forward with a force capital F. Mass of the block is M. I want you to find what is the, or we are discussing it. Okay? We want to find what is the acceleration of the pulley and acceleration of the block. Now, as I said, that constraint relations is used in a compound pulley system. So what is a compound pulley system? Anybody having any idea about compound pulley? Riya, any idea about compound pulley?
Sir, maybe one end of the pulley is fixed.
Sorry.
One end of the pulley is fixed.
So there is no end of the pulley. Pulley is a round thing. So there is no end to this pulley. Yes or no?
No, I mean one of the string.
Okay. Now, if in a pulley block system, please follow this. Please remember it. It's a very simple way to identify compound pulley system. If in a pulley block system, any one of the pulley is a moving pulley. That is, it is changing its position, right? Moving pulley to rotate bhi hota hai. So rotation mein, it's not a compound pulley. It should change its position, right? Then the entire system becomes a compound pulley system. So here there is only one pulley and that pulley too is moving. So it's a compound pulley system. If there are 1000 pulleys, 999 are fixed and only one is also moving, then also it's a compound pulley system. I hope all of you understood this. Yes or no?
Can you repeat? Your voice was breaking for me.
My voice is breaking to all of you? Is it
No,
breaking
only
all
for
of you?
me. It
Achha,
was mine.
okay. If in a pulley block system, if the pulley is changing its position, right? If the pulley is changing its position, then it's a compound pulley system. Okay, this is a compound pulley system. Now, I hope all of you understood this, right? So now let's draw the free body diagram of this. I'm drawing the free body diagram for this pulley. Its tension is always directed away from the body. Tension is always directed away from the body. And for this block, the free body diagram will be tension T in the forward direction, mg in the downward direction, and normal reaction N in the upward direction. So pulley has a different acceleration AP and block will have a different acceleration AB. Now, remember this, kids, please remember it. Whenever you have a compound pulley system, always go for different accelerations for all the constituent bodies. फिर से बोल रहा हूं, जब भी आपको कंपाउंड पुली सिस्टम दिखाई देता है, आप हर ऑब्जेक्ट का एक्सीलरेशन आपको अलग अलग लेना है. Whenever you have a compound pulley system, you have to take accelerations of all the objects as different accelerations. Okay. Now, the net force acting on this pulley, all of you. What is the net force acting on this pulley? In the forward direction, of course. It's F minus 2T is equal to mass of the pulley is 0 because it's an ideal pulley into acceleration of pulley AP. So from here I get tension T is equal to F by 2. I hope all of you understood this. Yes or no?
Yes, sir.
सब बोलेंगे भाई हाँ या ना?
Yes, sir.
Sir, और एक बार बोलेंगे वॉइस क्रैक.
the net force acting on the pulley in the forward direction is F minus 2T. Right? And this is equal to mass. Mass pulley का कितना है? Mass of the pulley is 0 into AP. Right? So tension T is equal to F by 2. Clear?
Yes, sir.
Yes.
For the block in the forward direction, its tension T is equal to mass into acceleration of the block. Right? So what is tension
Yes.
T? So what is tension T? Tension T is F by 2
By 2.
is equal to mass into acceleration of pulley, and this is equal to F by 2m. Right? So we found the acceleration of the, no, this is not P, this is B. Acceleration of the block is AB. AB. This is AB, right? F by 2m हुआ ये. Clear है बेटा सबको? लोनिका, वैदेही, शानवी, अर्पिता, रिया,
Yes, sir.
Yes, sir.
तनुश्री,
Yes, sir.
तनुश्री, नाइशा.
Yes, sir.
Yes, sir.
Okay, that's great. So now AP, we want to find what is AP. Okay. So, but we don't have any other equation to solve. We have already solved 2 equations, right? Now it's the time for writing constraint relations. Once you have identified a compound pulley system, always remember that there will be at least one equation for constraint relations. At least one. Okay, there can be multiple also if there are multiple moving pulleys, but at least one equation for constraint relation will always be there. Okay. So now let's follow the steps. All of you, please see in your notebook what was the first step. It said, after identifying that it's a compound pulley system, what you need to do is identify the fixed point. That point can be in the system and outside the system also. So I take this point as the fixed point. Okay, this is the only fixed point in the system. The string, I am considering the system to be string, pulley, and block. Yes or no?
Yes.
Yes, sir.
So this is the fixed point. Now, one more thing which we are considering here is the radius of the pulley is very small as compared to the length of the string. R is representing the radius of the pulley. So you can ignore the dimension of the string on the pulley. Okay? L is representing length of the string. And that is the constraint here. Okay? Now, after identifying the fixed point, what we need to do is, we need to identify the moving objects. So which are the 2 moving objects here? The pulley and the block. Yes or no? All of you.
Yes, sir.
The
Yes,
pulley
sir.
and the block are 2 moving objects here. Now, assign them the positions. We need to assign them the positions from this fixed point, right? So this is XP and this is XB. Because I am considering this dimension of pulley to be negligible. So, just a second. This length, even if I mention it from here or from here, it's one and the same, right? I hope all of you understood this. Yes or no?
Yes.
Yes, sir.
ठीक है. श्रेया को समझ आ रहा है कि नहीं आ रहा है?
हाँ, sir.
ठीक है. So XP and XB are the lengths. Now, what is the next point? All of you read the next point. One of you please read it
The
aloud.
above equations to find the range.
नहीं. Mention, write the length of the string in terms of these assigned positions. लिखा है ना? This one,
Yes.
write the length of the strings in terms of these assigned lengths. Right? So we have done the first 2 points. We will do the third point now. So what is this third point? Length of the string. Where is the length? Let me highlight it. This is the length of the string, right? So let's assume that the length is L. and this L is equal to what? It's XP. This portion, I am ignoring this portion because the radius of the pulley is very small, right? So remove it. XP plus, how much is this length?
XP minus XP.
Very good. It's XP minus XB. So L is equal to 2XP minus XB. Now, this is the constraint relation. Okay. But now what we will do is, we want to find the relation between the accelerations of these objects, right? Because why do we want to do that? Because we know the acceleration of one of the objects. So using the relation between these two, the accelerations of these two objects, we can find the relation of the unknown object. Sorry, unknown relation of the object, right? Unknown acceleration of the object. So we differentiate it. तो करते हैं differentiate इसको. It's 2 dxp by dt minus dxb by dt. So what is this? L is a constant, all of you, yes or no? The
Yes,
string
sir.
length is a constant. So what is differentiation of a constant?
0.
0.
Differentiation of a constant is 0. Tanushri, understood or not? Tanushri, Jayanti, Avirupa Nath.
Yes, sir.
Okay. So then it is dxp by dt.
Then
What is
it's
this?
it's 2 VP minus VB.
Why it is Vp? Why it is not minus Vp? प्लस Vp क्यों लिखोगी? माइनस Vp क्यों नहीं लिख सकते उसको?
Because it's in the direction of acceleration.
It is increasing. Always pay attention. Why? See, there is a very important reason for it. Since xp is increasing, जब आप उसको आगे खींच रहे हो पुली को, तो xp is increasing, right? So the change in xp with respect to time is positive change. That's why we will write it as Vp. I hope all of you understood why it is positive. Minus, is xb increasing or decreasing? When the pulley is moving forward, the block is moving forward or backward?
So
All of you.
decrease.
नहीं, why decreasing? उस पुली को आगे खींचोगे तो ब्लॉक आगे ही जाएगा ना, पीछे कहाँ जाएगा? ब्लॉक पे पीछे कोई फोर्स लग रहा है क्या?
No.
नहीं लग रहा है ना?
So it's
There is no,
increase.
it will increase only. Naisha, you understood or not?
Yes.
Okay.
सर मुझे नहीं समझा आपने अभी क्या बोला.
आप कौन?
श्रेया.
श्रेया जी, देखिए, सुनिए ध्यान से. कहाँ चली गई आप? हाँ, श्रेया,
Yes.
XP की वैल्यू इंक्रीज कर रही है कि डिक्रीज कर रही है बेटा, जब पुली आगे आ रहा है तो?
इंक्रीज करिए.
ऑब्वियसली इंक्रीज कर रहा है, तो रेट ऑफ चेंज उसका क्या होगा टाइम के साथ? पॉजिटिव होगा, नेगेटिव होगा?
पॉजिटिव.
इसलिए Vp लिखा प्लस Vp.
अच्छा.
अब
ओके.
ये माइनस है बीच में. अब ब्लॉक बी जो है वो आगे मूव करेगा या पीछे मूव करेगा?
वो भी आगे ही मूव करेगा.
आगे ही मूव करेगा. तो उसका रेट ऑफ चेंज पॉजिटिव हुआ या नेगेटिव हुआ? XB की वैल्यू इंक्रीज करेगी, डिक्रीज करेगी टाइम के साथ?
इंक्रीज करेगी.
ऑब्वियसली इंक्रीज करेगी. सो इट इज VB,
ओके.
राइट? Once again, when you differentiate it, it's 0 to dVp by dt minus dVb by dt, right? So this is 0 is equal to
Right.
2AP minus AB, and from here we have AB is equal to 2AP.
ओके. ठीक है.
So we can easily write AP as it's AB by 2, and this is F by 4M. So this is how we write constraint relations. I hope all of you understood this. Yes or no?
यस.
Yes, sir.
Yes.
इसको copy करो.
Yes.
Copy it quickly, and then we will solve some more problems based on this.
एक्सक्यूज मी सर.
बोल भाई.
सर एक क्वेश्चन में मोटर शाफ्ट भी लगा दिया था उन्होंने स्ट्रिंग के ऊपर, लाइक जो
हाँ,
वाइंड
तो-
करता था.
हाँ,
तो
तो
करेगा क्या, मतलब उसमें करना क्या रहता है?
सवाल भेज, फिर बताऊंगा क्या होता है.
ओके सर, क्लास के बाद या अब?
नहीं, आज नहीं.
ओके.
भेज देना, मैं बता दूंगा.
Okay, sir.
इसके बाद मेरी एक और क्लास है अभी 10 से 11, अभी तो नहीं बता पाऊंगा।
Okay, sir.
Once you're done writing it, please type done in the comment window. Huh? All of you noted it? लिखा बेटा सबने? नाइशा noted?
हाँ सर।
Yes, sir.
No, sir. No, sir. Okay.
लिखो लिखो जल्दी लिखो. Once you're done, just type done. Huh? So let's solve one more problem based on this. Okay. So this is a fixed peg here. right? This is fixed. It cannot move. Okay. Okay, so these are two blocks which are kept on a frictionless horizontal surface, and block A is pulled with a force of, say, I'm not interested in this force. I just say that block A is moving with a velocity of 4 meters per second. We want to find what is velocity of block B in this case. This is fixed, huh? The black peg is fixed. Okay. Now, what will you do? How to deal these type of cases when, the important thing is radius is always small as compared to the length of the string. How many strings are here? Any one of you, how many strings are here?
One.
One, right? There is only one string here. Now, and the pulleys attached to the blocks are considered as an integral part of that block only. Pulleys attached to the block are considered as a part of the block only. Okay. So now what you will do is write constraint relations in this case directly. So identify the fixed point. We already have identified it, right? What is that fixed point? It is the peg. This is the fixed point, right? Now from this, draw a line, a reference line. And from this fixed line, from this reference line, identify the moving objects first. A and B are the moving objects. Once you have identified the moving objects, assign them positions. So this is XB and this is XA. I hope all of you understood this. Yes or no?
Yes, sir.
This is XB and this is XA. So now write the length of the string in terms of these XBs and XAs. So XB, XB, XA, XA, XB. So there are 3 XBs
2 x's.
and 2 XAs, right? Now differentiate this. It's dl by dt. Now it is 3 dxb by dt plus 2 dxa by dt. Okay. Now tell me that this is a constant and this is 0. Now tell me whether xb is increasing or decreasing, all of you.
It's increasing.
ध्यान से देखो, रेफरेंस लाइन के पास जा रहा है कि दूर जा रहा है वो?
Decreasing.
It is decreasing, yes. XB is decreasing because B is moving towards this reference line. So XB is decreasing. So this is minus 3 VB. Rate of change of position is velocity, right? Plus XA is increasing or decreasing, all of you?
Increasing.
Increasing.
So it is 2 VA. So from here we get VB is equal to 2 VA by 3. And this is 8 by 3 meters per second. I hope all of you now understood how to use constraint relations. Yes or no?
Yes.
हाँ ना बोलेंगे भाई सब लोग.
सर
हाँ,
ये
सर।
साइन वाला पार्ट मुझे नहीं समझ आ रहा है।
अरे हे देवी, तुम आराम से समझो ना इसको. कोई इसमें कुछ भी रॉकेट साइंस नहीं है बेटा. तुम रेफरेंस लाइन समझी कि नहीं समझी ये बताओ पहले.
यस सर।
कौन सी है रेफरेंस लाइन यहाँ पे? कलर
ये
बताओ
जो
उसका.
पेग से पास कर रही है वो
कलर बताओ कौन सा है. पिंक कलर
रेड
की.
कलर।
रेड और पिंक कलर जो तुमको समझ में आता है. बहुत बढ़िया. अब बताओ एक बात, जब ए आगे मूव करेगा तो बी कहाँ जाएगा? अगर ए फॉरवर्ड मूव करेगा, एक्स एक्सिस में मूव करेगा, तो बी कहाँ जाएगा? नेगेटिव एक्स में जाएगा या पॉजिटिव एक्स में जाएगा?
पीछे की तरफ।
क्यों जाना चाहिए पीछे, उसको बताओ। अच्छा, तुम किसी चीज को आगे खींचोगी, अगर ए को तुम आगे खींचोगी तो बी पीछे जाएगा क्या?
नहीं, आगे
ये
आगे
कौन सा फिजिक्स पढ़ा हुआ है बताओ। अच्छा, आगे जाएगा ना बेटा, पक्का ना?
यस।
देखो, इसमें गलती नहीं
यस।
करना है, ये सब तो इसमें कुछ है ही नहीं। इफ यू विल पुल ए फॉरवर्ड, बी विल मूव फॉरवर्ड, यस और नो?
यस सर।
Very good. Now, if B moves forward, is it moving towards that reference line or away from the reference line?
अवे फ्रॉम द रेफरेंस।
हे देवी, फिर से अगर B, हिंदी में समझाता हूं, अगर B उस रेफरेंस, अगर B फॉरवर्ड आ रहा है, B कहाँ आ रहा है बेटा? फॉरवर्ड आ रहा है, ठीक है?
यस।
तुम घबराओ मत, इसको बड़ा मत समझो, ये है ही नहीं बड़ा, इसकी औकात नहीं है कुछ। तो अगर ये फॉरवर्ड आ रहा है, तो ये इस पिंक कलर की लाइन के पास आ रहा है या दूर जा रहा है?
पास।
अब तुमने फिर क्यों बोला था दूर जा रहा है? अंग्रेजी में अभी बोला था ना तुमने।
सर कंफ्यूज हो गई थी।
क्यों? इसमें क्या कंफ्यूजन है? चलो,
यस।
अच्छा, अब मुझे बताओ, एक्स भी अब डिक्रीज हो रहा है कि इंक्रीज हो रहा है?
एक्स भी डिक्रीज हो रहा है।
तो डिक्रीज होता है तो नेगेटिव लिखते हैं, पॉजिटिव लिखते हैं। तेरे बैंक अकाउंट में खाते से तेरे 10 करोड़ रुपया निकल गया, उसको माइनस लिखेगी प्लस लिखेगी?
माइनस।
तो माइनस लिख उसको वहां पे, समझी?
यस सर।
पक्का?
यस सर।
वेरी गुड। चलो, तो आज का होमवर्क सुनो भाई, पहले तो जल्दी से, जरा दूसरी क्लास का टाइम हो गया, फटाक से। हाँ, आई टेल यू अबाउट द होमवर्क क्विकली। देखिए, ये चैप्टर है, इसको आपको पढ़ना है, ठीक है? Newton's laws of motion. All of you should read. You should read the textbook. You must read the textbook. Okay. None of you will skip reading the textbook. समझ आया नहीं आया सबको?
हाँ सर।
कोई मुझसे ये नहीं कहेगा मैं नीट की तैयारी कर रही हूँ, मुझे अंग्रेजी की जरूरत नहीं है, इसलिए मैं पढ़ना नहीं चाहती हूँ, मैं नहीं पढ़ूंगी या नहीं पढ़ूंगा। ऐसा कोई भी नहीं होना चाहिए, ठीक है? यू हैव टू रीड द टेक्स्ट बुक। ये सब पढ़ो। कहाँ तक पढ़ना है? 5.4 आर्टिकल कंप्लीट करना है। यू नीड नॉट हैव टू रीड दिस article of pseudo forces, ठीक है? Till 5.4 read the article. Okay, complete the text. Now start with solved examples 1 2 3 4 5 6 till 8. Solve except for the ninth one, except for the ninth question, solve all the questions. Understood? Solved examples. Except for ninth solved example, solve all the examples. Solve, ठीक है? Then exercises में you can solve this complete exercise. You can solve 42 questions, right? But try doing as many as you can. But which ones are mandatory here? So the mandatory questions मतलब जो तुम्हें करना ही करना है, ठीक है? क्लास में घुसने से पहले करके आओगे ये 32, 30, 31, 32, 27, 27, 30, 31, 32, 34, 33, ठीक है? हेलो?
यस सर।
All these
Yes,
questions
sir.
are mandatory. You need to solve it before joining the session. 27, 30, 31, 32, 33, 34. ठीक है? And this one, 38. These questions are compulsory. Rest of the questions you need to complete it, but try completing it in 1 week. You still have 1 week to go. So try doing 5 questions a day. That will make, you'll be able to do these questions. Complete this exercise. Okay? Do 5 questions a day. That is more than enough. कर सकते हो इतना?
Yes sir.
चलो.
Yes.
So anything else you would like to ask or say? एनी वन
सर
ऑफ
बस वो कैलोरीमेट्री वाला कल तक भेज।
वो भेज दूंगी, वो जो याद है। तुम टेक्स्ट करो, पहले टेक्स्ट में डालो उसको जल्दी से।
हाँ हाँ, मैं अभी क्लास के
हम्म।
बाद डाल।
चलो बाय, टेक केयर।
थैंक यू सर।
राजश्री
Okay,
डागा,
sir.
अगली बार से
So-
क्लास टाइम पे आ जाना, राजश्री डागा।
Yes, sir.
हाँ